Alright, let's look at the homework 3.2, problem number 6. Alright, so we want to find the first derivative and the second derivative. Alright, so let's do that. Alright, so the first derivative, so f prime of x is equal to, alright, so this is, we're going to use the quotient rule. Alright, square the bottom, so you have x squared plus 1 squared. Alright, then we have, let's see, so the derivative of the top would be 2x. Right, and times the bottom guy, which is x squared plus 1. Minus top guy, which is x squared minus 1. Right, then multiply by the derivative of the bottom guy, which is 2x again. Right, then if you simplify that, you're going to get, alright, so you have x squared plus 1 on the bottom. Alright, then let's see, so we have 2x in common, so I'm going to pull that out. Alright, so we have a 2x here. Alright, then you're going to have actually x squared plus 1, then distribute the negative sign, so it's a negative x squared plus 1. Right? So you can see that there's x squared here and there's x squared there, cancel out. So we end up getting, let's see, 1 plus 1 is 2, 2 times 2x is 4x over, alright, x squared plus 1 squared. Right, then so this is the first derivative, so let's type it in. So we got 4x and all over x squared plus 1 squared. Alright, then we're going to find the second derivative. Alright, so we're going to have to take the derivative of that again. So we have f double prime of x is equal to, alright, square the bottom guy, so we can do that. Alright, x squared plus 1 to the 4th power, because it's already squared. Alright, and derivative of the top would be 4. And then you're going to have the bottom guy is x squared plus 1 squared. Right? Then minus. Right? Top guy, leave the top guy 4x. Alright, then multiply by the derivative of the bottom guy. Alright, we can't use the product rule. Later on we can use a little bit better method, but let's use the product rule there. So if you take the derivative x squared plus 1, square would be same thing as multiply by itself, right? So derivative of the first guy would be 2x. Then you have x squared plus 1 plus first guy is x squared plus 1. Then derivative of the second guy would be 2x. So I'm just using the product rule there. Then this is going to be, you can actually see that this is going to be just, let's see, 2 of the same thing. So it's going to be 4x times x squared plus 1. Alright, so we see 4x x squared plus 1. Right? Alright, so we have that, and then what we can do is we can simplify from here, and let's see, there are a bunch of common factors there. Alright, I'm going to leave the bottom alone for now. X squared plus 1 to the 4th power. Alright, so what's in common? There's a 4 is in common, and so I'll take that 4 there. And also, there's an x squared plus 1. I'll circle this one so that I know that there's another x plus 1, and here's an x plus 1. So we can pull 4 times x squared plus 1 there. Alright, then what's left would be x squared, so these guys. X squared plus 1, and then you have a minus, right, and the full x squared. Right, so what you get is, let's see, one thing we can do is we can cancel this one of these guys, and the 4 becomes now 3rd power. Alright, then this is going to be right here is going to be simply 4 times 1 minus 3x squared divided by x squared plus 1 cubed. Alright, so let's write down the second derivative. Alright, so we have 4 1 minus 3x squared, then whole thing divided by quantity x squared plus 1 cubed. Alright, so that's the second derivative. Alright, then let's say tricks to see. So f prime equal to 0 when f has a horizontal tangent line, and f double prime is equal to 0 when f prime has a horizontal tangent line. Alright, f prime is negative, means that it's decreasing, so this guy is decreasing. Positive when this guy is increasing. Alright, if f double prime is negative, so f prime is decreasing, and positive when f prime is increasing. Alright, f prime is negative. We have to talk about concavity. So concave down is, so if the second derivative is negative, it has to be concave down. So down, and when it's positive, it's concave up. Alright, actually we haven't talked about the concavity yet, so this wasn't a very fair question, but if second derivative is negative, f is concave down, and if positive, f is concave up. Alright, let's double check, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.